Okay, this lecture is on judgment and decision making. Some of the learning objectives for today are that after hearing this lecture and reading the module, I hope that you'll understand the process for making rational decisions, know what is meant by the term bounded rationality, and then understand some of the systematic biases that affect our judgment and decision making. So this lecture will go over some key terms related to judgment and decision making. I'll review what a rational decision consists of. I'll then discuss the term bounded rationality, and then I'll review several prominent biases in our decision making, and then end with how we can make better decisions by fixing our decision making. Okay, just in terms of some key terms. When we talk about judgment, we're talking about providing an estimate of something. And so the most common judgment task that psychologists study is to give an estimate of a particular quantity. So for example, how many pieces of candy are in the jar. But another type of a judgment problem would be to make an estimate of how many students will apply to Miramar for admission in 2020. In contrast, decision making typically involves selecting from a small number of alternatives. So questions like, what should I order off the menu, or which job candidate should we hire? It's about making a choice between a couple different alternatives. So today we'll be talking about both judgment and decision making, but that's just how to differentiate the two. Okay. So what does it mean to make a rational decision? Rational decision making is a multi-step process for choosing between alternatives that follows an orderly path from problem identification through solution. And some of the features of rational decision making are that it's based on logic, is that rational decision making is objective instead of biased, and it involves analysis instead of using one's subjective judgment or even using one's insight, which is often called going with one's gut feeling. Okay, so what exactly is a rational decision? Well, one way to think about it is you might start by thinking about your decision to attend college, and specifically what process you use to decide to take classes here at Miramar. Alternatively, perhaps some of you are considering transferring one day to another college. How would you go about making the decision about whether you want to transfer and where you might go next? When it comes to making important life decisions, decision scientists, that is, people that study the science of making decisions, they've come up with a process for how to make good decisions. And that's what this looks like. So decision scientists have suggested that rational decision making involves a 6-step procedure. The first step is to define the problem. So for example, how can I select the right college to attend? The second step would be to identify criteria necessary in order to judge multiple options, that is, how to judge the quality of different colleges. So for instance, certain criteria might be especially important to you, like the location, the affordability, the types of degree programs that are offered, perhaps what student life is like. Once you've established the criteria that you're going to use to differentiate between the different options, you then need to weigh the criteria. That is, which is the most important? Is it location? Or is it affordability? Or is it the type of degree that are offered? The idea is that you'd have a rank ordering of which criteria are the most important. Next, what you would do is generate alternatives. So these would be the schools that you've been accepted to, or that you think you have a chance of being admitted to if you still are going to apply. What you're then going to do is rate each alternative on all of the criteria that you identified, and then come up with a way to compute an optimal decision. Hurts your brain, doesn't it? Yeah. So as you can see, making an optimal decision is really quite labor intensive. It involves time, effort. So it's a lot of work. So most of the time, we don't make our regular, routine, everyday decisions using this optimal strategy of rational decision making. Oh, there we go. Instead, we often follow the principle of bounded rationality. The principle of bounded rationality suggests that we have cognitive limitations that prevent us from being fully rational. What are some of these cognitive limitations? Certainly, there are time and cost constraints that limit the quantity as well as the quality of information that is available to us. You can think about, we have the internet available to us. We can do all kinds of research. Think about the last big decision you had about what to purchase, even where to go out and have a meal. You know, we can read reviews on everything, but it just takes a lot of time and effort, and sometimes you just think, oh, it's not worth it. So we have limitations on the time and cost associated with getting information. We also have limits on our own perceptions. That is, there's limitations with our perceptions, our memory, and our intelligence. That is, the amount of information that we can take in, the amount of information that we can remember, and there's just different limitations with our ability to use information wisely or correctly, which is a function of intelligence. So the short of it is that because of all of these limitations, we're not capable of being fully rational all the time. So another way to think about the way that we think about the world and the way that we make decisions is to think about having these two different systems. So system one is our intuitive decision-making system. It typically is fast, automatic, effortless, and uses emotion. In contrast, our system two is our more deliberate decision-making system, which is slower, requires conscious effort and awareness, is effortful, and logical. The 6 logical steps of decision-making outlined earlier describe a system 2 process. Bounded rationality is more consistent with system 1 thinking. And indeed, system 1 thinking is how we make most of our decisions most of the time. Indeed, in most situations, using our intuitive system 1 is really quite sufficient. Our system 2 thinking should really only be used for our most important decisions, not every single decision. It wouldn't be functional at all to go through our life going through that 6-step process to think about every single decision that you needed to make. So most of the time, if you think about the hundreds of small decisions that you need to make throughout your day or throughout your week, we use our System 1 thinking. Now, part of our System 1 thinking involves the use of heuristics. Heuristics are mental shortcuts that people use to make judgments quickly and efficiently. Heuristics are very functional in that they help us cope with the complex environment surrounding our decisions. Most of the time, they're very functional and they serve us very well. Unfortunately, they also lead to systematic and predictable biases. Okay, so let me give you just one example of a heuristic, and there are many, and I'll review several later. But one heuristic is known as consensus implies correctness. Okay, consensus implies correctness. What does consensus mean? It just means that many people agree. And a heuristic is to say, if many people agree, they must be correct. Therefore, if I know that many people feel a certain way, that they must be correct. So I won't take my own time or effort or energy to do my own research or to try to find out as much as I can about the topic. I'll just use the heuristic that if most people agree, well, that must be correct. And indeed, many times using the consensus implies correctness heuristic will lead to a good decision. But of course, not always. And indeed, we've often been told that if many people believe in a stupid idea, it's still a stupid idea. So there's times when following the crowd isn't the best choice. So let's go over some of these biases that we have. So biases refer to predictable, systematic mistakes that influence our judgment. And what you can see is that I've got a target here, and you can see that the arrows are kind of missing the target all on the right side, so kind of in a predictable way. So that's an important feature about biases, is that we mean to have a bias, we're making a mistake, but we're making a mistake in a consistent and predictable way. So here's a list of some of the judgmental biases, as well as the types of decision errors that decision scientists have determined that people make on a regular basis. Now, this is actually a very short list, if you can believe it. There's a list of a long list of judgmental biases that psychologists and decision scientists have studied. So I just want to give you a short list and describe each one of these biases so you can hopefully try to recognize them in your own decision making. So this is an alphabetical order. I won't necessarily go over in this order. All right. So as the first example, I'll start you with this problem. So here it is. Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Which is more probable? A, that Linda is a bank teller, or B, Linda is a bank teller and is active in the feminist movement. In other words, that she's a feminist. Okay, so think about that description of Linda, and then think about whether you think A or B is more probable. That is, what is more likely to be true. Have you thought about it? All right. Well, if you've said that you think that it is more likely that Linda is both a bank teller and a feminist, you've made an error in judgment. We know, based on the conjunction rule of probability, that it would be much less probable that Linda would be a feminist and a bank teller. To explain why this is true, take a look at the circles in the upper right-hand corner. You can think of the blue circle as representing all people in the world that are feminists, and the green circle representing all people in the world that are bank tellers, and the overlap, where the arrow is pointing, as all people that are both feminists and bank tellers. So there's more people in the world that are just bank tellers. There's fewer people in the world that are both feminists and bank tellers. Therefore, going back and looking at the choices, it's much more likely, because there's just more of them in the world, that Linda is a bank teller rather than being both a bank teller and a feminist. But why is it so common? And I'm sure if you thought that Linda was a feminist and a bank teller, you wouldn't be alone. Indeed, most people make this incorrect judgment. And the reason is because people rely on the representativeness heuristic. Linda is judged as similar to stereotypes about feminists, and this information is weighed too heavily. We can say that it skews our judgment. Keep in mind, if we go back and we look at the information, we know that Linda is 31, single, outspoken, and very bright. Does this necessarily mean that she's a feminist? I don't think so. You can be all those things and not a feminist. She also majored in philosophy. Doesn't necessarily mean that she'd be a feminist. As a student, she was deeply concerned with issues of discrimination and social justice. Okay, well, I would think some feminists aren't care about that. That seems right. And also participated in anti-nuclear demonstrations. Doesn't necessarily seem related to feminism. Okay, so there's some pieces of information that people would suggest fit the stereotype of feminist, and they treat that information as very diagnostic, and it pushes them to make this conjunction error. Okay, ignoring rules of probability. Okay, so that's due to the representative heuristic. That description just made Linda seem so representative of a feminist. Okay, so to define representativeness heuristic, this is a heuristic in which the likelihood of an object belonging to a category is evaluated based on the extent to which the object appears similar to one's mental representation of the category. Okay. Okay. All right. So let's do another example problem. Consider the following information. In a company called CompuSoft, which is a computer software firm or company, there are 20 office staff who consist of people that do administration, secretarial work, as well as sales. And there are 80 programmers or analysts, whatever you want to call them, 80 programmers. Melissa Jones works for CompuSoft. She is a tall, attractive woman, age 28, and has worked at CompuSoft for 5 years. She knows how to type, communicates well with people, and loves her job at CompuSoft. Her hobbies are crossword puzzles, painting, and dancing. The question is, what is the likelihood that Melissa Jones is office staff? Okay, so you've got office staff workers, and you've got programmers and analysts. Okay, so take a look at this information again. You've got the description. Now I want you to provide a rating of what do you think the likelihood is that Melissa Jones is office staff. Okay, have you thought about your answer? Okay. So the correct answer is that there's a 20% chance that Melissa Jones is office staff. Okay, this is based on the idea that there are 100 employees, 20 of them are office staff, and 80 are programmers or analysts. So there's 20 out of 100 is 20%. So it's a 20% likelihood that Melissa Jones is office staff. Now, if you said it seemed very likely, as in 60%, 70%, 80%, 90%, or 100%, that Melissa Jones was office staff, you would again be relying on the representativeness heuristic. Why? Because there was certain information that made her perhaps seem more stereotypical of somebody that would be office staff and less like a programmer or an analyst. Okay? So perhaps the information that she communicates well with other people made you think, well, that doesn't sound like a programmer to me. But if you really look at the other information, knowing how to type, having a hobby that's crossword puzzles, painting and dancing, this really isn't information that would be diagnostic of either one. So there's very little information here that should give you a strong feeling that she's one or the other. But again, relying on the representative heuristic, there's a couple pieces of information there that really seem to push for being an office staff versus a programmer analyst. And because of that, people tend to give a higher probability that she's an office staff instead of the correct answer, which is 20%. Okay. So because of over-reliance on representativeness, people tend to overlook or ignore base rate information. Base rate information is information about the frequency of members of different categories in the population. So we were given the information that there are 20 office staff and 80 programmers. So there's a 20% base rate of office staff and an 80% base rate of programmers or analysts. And so that's the information that we need to use. But instead of using that base rate, people rely on the representative heuristic because the information that is given about Melissa is more vivid, it's more concrete, it's more easily usable. Okay, so it's just a lot more easy to use representativeness than to judge the probability. So we underemphasize or even ignore base rate information about the proportion of staff that are office staff versus programmers in the company. All right, so let's do another example. Here's the question. Are there more words in English that begin with the letter K or have K as the third letter? Might help to start creating a short list. Try to think of some words. What words come to mind that either begin with the letter K or have K as the third letter? Did you think about it? It turns out that there are 3 times as many words that have K as the third letter. Interesting. I know when I started making my list, it was a lot easier to think of words that begin with the letter K instead of words that have K as the third letter. I was very tempted to believe that there'd be more words in English that begin with the letter K. We'll come back to this idea. Here's another example. In the United States, estimate the number of people that die each year from the following causes: diabetes, fires, gun homicides, lung disease, pneumonia, or traffic accidents. Okay, so if you had to come up with a number, what would be the number of people that die each year from those causes? Okay, these are just in alphabetical order, by the way. So think about your numbers. So here's the real numbers. As you can see on the list, it's much more common for people to die of lung disease, followed by diabetes, and then pneumonia. Interestingly, people are more likely to estimate that people die from gun death or gun homicide than pneumonia. Why is this? Well, for both of these two examples, people often rely on something called the availability heuristic. This is a heuristic in which the frequency or the likelihood of an event is evaluated based on how easily instances of it come to mind. So people tend to think that there are more words in the English language that start with K than with K as the third letter, because it is easier to think of words that start with K. And so that leads them to overestimate that words that start with K, are more common than words that have K as a third letter. Similarly, people overestimate the number of people that die from gun violence versus more common causes like lung disease, diabetes, or pneumonia. Why is this the case? Think about what you see on the evening news or what makes headlines. We often unfortunately see news about violent crime, and we don't often hear that people die of more mundane causes like diabetes or pneumonia. So because it's much easier to imagine somebody dying because of gun violence, because it's much more available and it comes to mind because we see it on the evening news, we overestimate how frequent that cause of death is versus the more common but less available to our mind causes of death like diabetes or pneumonia. So it's interesting that even physicians seem to rely on the availability heuristic. Although it might seem straightforward for a physician to observe people's symptoms and figure out what the disease is, it can be difficult. There could be symptoms that might be a sign of several different diseases or disorders. So do doctors use the availability heuristic, where they're more likely to consider diagnoses that come to mind easily? Several studies suggest that the answer is yes. So even physicians make their medical diagnoses based on what is most easily comes to mind. Something that I should say is that most of the time, they're likely to be correct. And that's the thing with heuristics, is very often these heuristics serve us fairly well. But there are times when they don't. And if you have ever known somebody that has been misdiagnosed by a physician, it could have been because they were presenting symptoms for a rare disease. And the doctor went with a much more common diagnosis because that's what they're familiar with. That's what came most easily to mind. All right, so that was availability. Okay, so I've got another example for you. Here's a question. Is the Mississippi River longer or shorter than 500 miles? Okay, so in order to answer this question, you have to think about how long is the Mississippi River. Okay, so think about that and then decide whether you think it's longer or shorter than that amount. So make an estimate for how long the Mississippi River is. Okay, did you think of a number? What if I was to ask you this question? Is the Mississippi River longer or shorter than 5,000 miles? Would that change your estimate? Well, it turns out that people use something called the anchoring and adjustment heuristic. This is a mental shortcut where people use a number or a value as a starting point and then adjust insufficiently from this anchor. The problem is that with this is that completely arbitrary values can influence our judgments. Why is this not advancing? Here we go. So how were estimates of the length of the Mississippi different based on the anchor that was provided? Did you notice that in the first case, you had a much shorter estimate of the Mississippi River? If I had asked you to give an estimate and I had given you the anchor of 5,000, your estimate probably would have been longer. It turns out that the actual length of the Mississippi River is about 2,300 miles. But whether you give an estimate that is much shorter than that or much longer would depend on the anchor that was provided. So anchoring and adjustment is something that happens in our everyday lives. You might notice this especially with your parents or your grandparents, who are often fixated with what things used to cost many years ago. So if you've ever heard them complain about the price of gas or reminisce about how much a hamburger used to cost when they were growing up, or even the price of homes, they may be anchored on the original prices of things, and they can't sufficiently adjust their judgment to understand why things seem so expensive now. That is, their own judgments haven't kept up with the rate of inflation. That is, the increasing prices of goods and services. I know I've often felt that way, remembering what things used to cost. Like a gallon of gas when I was growing up was a lot cheaper than it is now, I can tell you. So this happens quite a bit in our everyday life as we get stuck on certain values and we can't seem to update our judgments sufficiently because we're anchored on those original numbers. All right, let's do another example. Here's another problem. I'm going to have you imagine that the United States is preparing for the outbreak of an unusual Asian disease that is expected to kill 600 people. Now, I promise this is a problem that was studied a long, long time ago by decision scientists, and it's kind of an interesting time to be talking about this now, but this problem is many, many, many years old, okay? So, again, let's just imagine that the U.S. is preparing for an outbreak of an unusual Asian disease, and this is expected to kill 600 people. 2 alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the program's consequences are as follows. So, if the United States selects Program A, 200 people will be saved. But if they go with Program B, there's a 1 out of 3 probability that all 600 people will be saved, but there's a 2/3 probability, that is a 2 out of 3 chance, that 0 people will be saved. So think about which program you would choose. If you had to advise the president, would you go with Program A or would you go with Program B? So think about it and make a decision. Okay, now I'm going to give you the same problem, but I'm just going to, it's the same setup, that there's this unusual Asian disease that's expected to kill 600 people. Now these 2 alternative programs that have been developed to combat the disease are associated with the following numbers. So program C, if adopted, 600 people will die. But if you advise the president to go with program D, there's a 1/3 probability that no one will die and a 2/3 probability that 600 people will die. So which one would you choose? Would you choose program C or would you choose program D? Think about it and make a decision. Okay. So when this problem is studied, results indicate that given the choice between program A and program B, most people should choose A. And that when given the choice between program C and program D, most people choose D. But here's the thing. A and C are actually the same. That is, if there's 600 people, saving 200 means that 400 will die. And if 400 die, that means that 200 will be saved. So A and C are identical. It's also true that B and D are also the same. So if you look, there's a 1/3 probability that 600 people will be saved. That's the exact same thing as saying that there's a 1/3 probability that no one will die. If all 600 people are saved, no one will die. And then if there's a 2/3 probability that 0 people will be saved, that's equivalent to a 2/3 probability that 600 will die. Okay. You'll also notice that the reality is that A and B and C and D are strictly all of these things are equal. From a probabilistic, the only difference is that A and C are certain and B and D is probabilistic. Okay. So 1/3 probability of saving 600 people is really the same as 200 people saved. It's just one is certain and one is probabilistic. Okay, so why the differences? Why is it the case that if A and C are equal, people choose A when framed this way, but people don't choose C and they go on to choose D when framed that 400 people will die? Why is that the case? Why the difference in preference? This is known as a framing effect. This is a framing effect. And this is actually based on the work of Daniel Kahneman and Amos Tversky, two psychologists that went on to win the Nobel Prize in economics. They're very well known for this framing problem, and this is actually called the Asian disease problem, something that they studied decades ago. So what a framing effect refers to is the bias to be systematically affected by the way in which information is presented. So the first problem was framed in terms of saving lives, saving 200 lives. The worst case scenario is that everyone dies. There's 600 deaths. Framing the problem in this way, it seems like a gain. Okay? Saving 200 people seems like a gain. And what they established, not just in this problem, but in similar types of problems, is that people are very risk averse in these types of situations. In other words, they go with the certain choice. Okay, they want to lock in the possibility of saving 200 lives for sure. Now the second problem is framed in terms of losses. Okay, that's framed in terms of the 400 deaths. So the implied reference point is then the best outcome of no deaths. So when you start saying, well, there could be 400 deaths, our minds say, yeah, but the best outcome is that there could be no deaths. So in this way, this framing seems like a loss, like we've got a sure loss. And when we know that we've got a sure loss, what the research demonstrated is that people are more risk-seeking. That is, they take the probabilistic choice. That's why, going back here, we take program D. We go with the probabilistic options because we're hoping for the 1/3 probability that no one will die. Okay, it's kind of, you think about it like we're more willing to roll the dice. Notice, however, that C and A are the exact same. It's the exact same outcome. So while we were willing to go with program A in the first framing, many of us are more reluctant to go with program C, even though they're the exact same option. All right, so those are framing effects. And the more general effect that we can describe here is that when people feel as though they've got a gain, they take the certain gain. People would rather have a certain small gain. However, when people feel as though they're in a loss frame, that loss is certain, they're more likely to be risky and go with a probabilistic option, even though it's less sure and more risky. Okay? So people are conservative or cautious when they feel like they're in a gain situation, and they're risk seeking when they're in a loss frame. All right, here's another bias that we have, which is called confirmation bias. This is a tendency to look only at information that agrees with what we already believe. The phrase is that we, quote, cherry pick the information we take in, seeking and accepting only the evidence that supports what we already think. In other words, we reach up and we grab for the ripe cherry, the one that looks the best to us. Okay. Similarly, we reach out and we pick the information that looks the best to us. We cherry pick. So, a study by Fry and Stallberg had participants take an IQ test and then were told that their IQ was either high or low. Shortly afterward, they all had a chance to look at some magazine articles about IQ tests. Those who were told their IQ was low spent more time looking at articles that criticized the validity, that is the truth, of IQ tests. Those who were told their IQ was high spent more time looking at articles that supported IQ tests as valid, in other words, true, measures of intelligence. So this illustrates the confirmation bias. All the research participants wanted to think they were smart, and so they analyzed the available information in biased ways. People wanted to keep their beliefs intact, in this case, the belief that they were smart. And so those that were told that they were smart wanted to select evidence that would confirm that. People that were told that their IQ was low wanted to select evidence that would dispute the test. Okay, so the other things that we know related to confirmation bias is that people evaluate information that is consistent with their opinion differently than other information. So inconsistent information, that is information that is inconsistent with their beliefs or preferences, is critically evaluated in terms of the strengths and weaknesses. However, information that's consistent with our opinions, our values, and our beliefs tends to be accepted at face value. We accept it without really challenging it. We also know that people judge opinion-consistent information to be more credible and important. Okay? So information out there that supports our opinion tends to be judged as more credible and important than information that goes against our opinion. And we know that opinion-inconsistent information is more likely to be discarded. Okay. And so, especially in political times, it's often said that people go on social media and seek out their own echo chambers, whether it's Facebook or Twitter or other social media sites. people tend to gravitate towards other people that share their point of view. And they get stuck in their own echo chamber. That is, everybody repeating the same information, the same talking points, as a way to maintain their own beliefs. Okay, so this is a good example of confirmation bias. People just seek out opinions and information from others that is consistent with their own opinions. Unfortunately, this bias influences how we interact with other people. It's often been said that more heads are better than one. And indeed, when there's an important decision to be made in government or in business, it's often thought that a group of people should be responsible for making that decision. The idea is that we can get different ideas together and different opinions. People can exchange information, and the best solutions to problems can be found. Unfortunately, there's quite a bit of research in psychology which suggests that this doesn't necessarily happen. Several studies of group decision-making show that people are more likely to mention and repeat information that supports their own initial opinion. Why do they do this? Well, it could be for strategic reasons. That is, they have a preferred solution, so they go in advocating their own solution, and they say all the information that supports their initial opinion, what they wanted to do before the group discussion even happened. Another reason is they want to manage their own impression. It looks kind of weird to argue against your own point, so people go in and they argue for their own point. They manage the impression that others have of them. It's also thought that in a group decision-making situation, it's a norm. That is, it's just kind of the way we do things in a conversation, to be an advocate, to support your own point of view. And then finally, people believe that their information is just more credible and important than other people's information. So ironically, it's often the case that when we get together with other people, we're not there to hear what other people think as much as just mention and repeat information that already supports the opinion that we had entering into the group conversation. All right. So, as a final bias that I'm going to review is the overconfidence bias. Okay, so this is the bias to have a greater confidence in your judgment than is warranted based on a rational assessment. Okay, so it's often been said that people have a bias blind spot, which is the belief that we're unlikely to be victim to all of these biases that I've just described. So we have the bias of overconfidence, and that we think, well, sure, other people will fall victim to those biases, but I won't. So perhaps our greatest bias is our overconfidence, the belief that those biases apply to other people, but not to us. So how can we fix our decision making? Well, the first and most important, I would say, is just to be aware of these blind spots. We all use heuristics, and we're all capable of making biased judgments, yet we all think we're better than everybody else. So the first step is to recognize we're not perfect decision makers, and to try to keep our confidence in check and not be overconfident, to realize that it's not just other people, but it's all of us that are capable of making these errors in judgment. The second thing is to go back and review some of these specific biases that I've gone over, and to just try to be more aware in our everyday decision making of when we're perhaps using the representative heuristic or the availability heuristic, or when we've become anchored on a particular number and we're not updating our judgment, or when things are framed in a certain way that might lead us to be more cautious versus risky. So, one, we have to be aware that these biases can affect us, and then be on the lookout for these specific biases as opportunities for us to perhaps make a less than ideal decision.